Good afternoon. Am I audible to you guys? Am I audible?
Yes, ma'am.
So in last class, we quickly discussed about what is data structure, what are different types of data structures, what is an abstract data structure, and we solved all divisions. So basically, there are two types of data structures: primitive and non-primitive. So can you tell me what is the difference between primitive and non-primitive? Can you give example? What is primitive and non-primitive data structure? Yeah, I'm asking what is primitive and non-primitive. Okay, in character groups are primitive and non-primitives. Means what's the difference?
Ma'am, in primitive data structure, it can store only one type of data.
Okay, and non-primitive. What was the characteristics of your any data structure? Non-primitive one means you can create the non-primitive data types with the help of primitive data types. Right? So there are two more types. One was linear and non-linear. Linear means in linear data structures, all the data items are arranged in a linear sequence. And in non-linear data structure, the data items are not in sequence. They are not arranged in particular way. Then another three things was share this with us. My writing period, so this using the quantity. What are the different names? One is linear. Linear already mentioned where everything is arranged in an order. Apart from this, there are non-linear data structures. That means there are no arrangements. They are not organized in a sequence. And apart from that, we have homogeneous. Homogeneous means where all the data items are of same type. Same type. Okay. For example, is your array. Another characteristics is non-homogeneous. That means elements may or may not be of same type. Okay. For example, your structures. structures includes any types of data types like even float, character, anything. So structure are non-homogeneous types of data structure. Then another property is category is static. Static means static means any idea? Static, another word is the dynamic. I guess I explained it in last sem. Static means whose size are fixed. Okay, size and structure associated with the memory locations are fixed in case of your static data structure like our array. Static, we always define the size of an array. But in dynamic, what happens? They can expand during the execution, or they can also shrink depending on the program. So their memory location keeps changing. It can also uh, means it can either grow or it can just decrease the size or location might vary. Okay, so example is the linked list. Linked list is a data structure. So these are the basic things we discussed in the last class. So today we will start the algorithm part. So about all these different types of data structure, it will be in different unit. For example, one unit is completely for stack, one unit is for queue, one is for tree, and so on. That means each of these different data structures is a one unit. Okay. So before discussing the data structures and the programs and all, we have to know a bit more about algorithm because the subject name is data structure and algorithm. So just bring down. Can you see the screen?
Yes, ma'am. No, ma'am. Oh, yes, ma'am. Yes. Now see.
So today we will see analysis of algorithms. I guess you guys already know what is an algorithm. So what is an algorithm? As per our previous classes, the semester, algorithm is nothing but a well-defined set of rules. Okay, with the help of these algorithms, we accomplish a particular predefined task. So we can say it's just a finite set of instructions or logic, and these are written in order, and we need, with the help of algorithms, we complete a certain predefined task. Okay? So this is not your program, it is basically the logic of your solution. So it is not dependent on your programming language. Programming language can be anything. Okay? But the main logic or solution of a problem is from the algorithm. So algorithms, you guys already know, we can represent in terms of like informal way, informal ways, or we can also describe in the form of flowchart. We can also describe in a pseudocode manner. And flowchart is the tutorial representation of your algorithm. And algorithm is just a step-by-step process. So can you tell me what are the basic properties of algorithm? So here I have just given an example. Remember, for any programs, we always start from the start, then in the end we write the stop. So in between there will be different lines. For example, here we need to design an algorithm to add two numbers and display the result. So first start will be there, then we will declare the integers here I'm going to take three integers a, b, c, then define the values of a, b, then add values of a, b, store the output of step 4 and keep it to c, then print c. Okay. And another way we can write is like this: start, add, get values of a and b, c, a, b, dismiss. So this part is more like a pseudocode. Okay, so both are correct. Pseudocode is also a formal way or informal high-level description of an algorithm. Right? So this part is your algorithm part. This is a pseudocode form. Just that we can write a solution to a problem in many different ways. Not necessarily you have to write exactly like that. You can have your own solutions. Okay. So algorithm is completely on you. Just that the logic should be correct. So what are the qualities of an algorithm? See, your algorithm should always have a well-defined inputs. Okay, there should be some input there in your algorithm. We always provide an external input to an algorithm. So similar way, if there is an input, we also should have at least one output. Okay, then every step of the algorithm should be clear and well defined. Okay. So another word is for that is that definiteness. That means every step of algorithm should be clear and well defined. Then finiteness. Finiteness means what? Algorithm should have finite number of steps. Cannot go like on and on. It cannot be enough. It should have a finite number of steps. Then every step of algorithm must generate correct output. It's not like you are just writing any steps. It should have a proper output. Okay. Then it should be user friendly also. Okay. User friendly means if it's not like only designer can explain it to the programmer, everyone should be able to understand what it's written. So algorithm should be also simple, easy to understand. Okay? And it should be like logical steps to solve all real world problems. Okay? And it should be language independent. As I already mentioned, it should not be dependent on any language. For example, like you can provide a solution with the help of a C language or Java or Python, nothing like that. Okay. And your algorithm should be extensible. Even different programmer, if you want to use your algorithm, it should be easily accessible by them. So why we need algorithms? You guys already know the basics of algorithm, how we should write the algorithm, what should be the qualities of an algorithm, right? So why do we need an algorithm?
Ma'am, to understand how the program works.
How the program works means you are designing the algorithm. It's not like program is designing the algorithm.
To simplify the program, I guess.
Yes. If like in real life world problems, we have bigger problems. So we always scale down these big problems into small steps so that it is easier for us to analyze the problem. Okay, it provides the scalability. if you have a big problem, it will help you to scale down the big problem into small steps. Then you can easily analyze the whole problem. And later you can just find the ultimate solution. Then it also gives you better performance. See, real world is not easily broken down into smaller steps. So if the problem can be easily broken into smaller steps, means the problem is feasible. Feasible means what? You have a very big problem. So when we see at the problem at first, it looks like it's not feasible, means it is not possible. For example, like many years ago, building an AI robot is not feasible, right? Means how can we think like a machine will do all the work, how a machine will think like a human, how a machine will do all the works a human can do. A few years back, it was like not feasible for us, but not anymore, right? They scale down the big problem into small steps. So to building an AI robot, they find out what are the other areas they have to explore first. So they did this in a small steps, and now it is very much possible to get an AI robot. Okay, so algorithms helps you to scale down the problem to smaller steps and analyze them, and it also provides you better performance. And in terms of theoretical importance, always got that part right. It helps us to break down a problem. Then it has also practical importance, because after knowing the theory only, you can implement it practically, right? So theory, both for theory and practical, we need to understand the algorithm. First, for any problem, you build an algorithm first, theoretical. Okay, once you know what should be the algorithm, what should be the steps to solve a problem, then you practically implement that solution with the help of your programming language. It can be any programming language. Now, if algorithm is a solution to a problem, obviously there will be certain issues also, right? So what can be the, okay, this question I already explained you why we need algorithms to understand basic idea of problems. It's an approach to solve problems, clear description and all. Okay. Now we will come to analysis of an algorithm. Now see, if algorithm is a solution to a problem, there will be certain issues also. Like what can be the possible issues? First is that how to design an algorithm. Okay, we know there is a problem and we need to find a solution. Now the problem is how to design the algorithm. Okay, so we need to first know how to design the algorithm by writing it in a like step-by-step procedure. Okay, so with the help of this set of instructions or step-by-step instructions, to follow them to solve a problem, it is under algorithm. Then we have to find out the efficiency of an algorithm. Okay. Now you have a problem, you have a solution to that, you also have an algorithm for that particular problem. Now you need to find out whether your algorithm is efficient or not. If your algorithm is not efficient, obviously there is no point to implement that algorithm. Okay. So now how will you analyze your algorithm to see the efficiency or the problem solving capability? Okay. So normally there are many ways to analyze an algorithm. Uh, there are many ways, means there are brute force, the divide and conquer approach, greedy algorithm and all. So the very deep methods you will learn in next semester. There will be a subject name is design and analysis of algorithm. Okay, so in that particular subject, design and analysis of algorithm, you will learn more about the algorithm. There are different ways to analyze the algorithm. There are so many different options: brute force, optimization, divide and conquer. You guys already learned about that concept. There are greedy algorithm and lots of other types of algorithms just to analyze an algorithm. In any way, in simple way, we analyze an algorithm or we check the efficiency of algorithm in terms of time and space. Okay, there are two terms associated with any algorithm. One is time complexity and one is space complexity. Time complexity means how much time your program or algorithm will take to run the program or execute the program based on the size of the. Okay, so time complexity is nothing but the running time of a program as a function of the size of the input. So input size matters. And second thing is the space complexity. Space means how much memory it is going to require to completely execute the program. Okay, so these two things are very important for any algorithm. You can analyze an algorithm or you can check the efficiency of the algorithm based on the time and space complexity. If you remember, uh, we always check the time complexity of linear search and binary search, and I told binary search is faster than linear search because it takes less time. Okay, if time complexity is low, that means that algorithm is fast. And if space complexity is low, that means your algorithm requires less amount of time, less amount of space. That means memory efficiency. So we analyze algorithm in terms of time efficiency and memory efficiency. Okay, this part clear? Okay, I'll come to this part too. I want to just tell you more things. Can you see the whiteboard? Can you see the whiteboard part?
Yes, ma'am. Yes.
So as I mentioned, we do the analysis of algorithms in two levels. Okay, two levels. One is before creating. Before creating, and second is after creating. Okay, so we always do analysis in terms of two level. One is before creating an algorithm, and second is the after creating it. So this before creating is also known as your priori analysis. Priori analysis. Priori. Priori. Priori analysis. So priori analysis is the theoretical analysis of an algorithm which is done before.
Excuse me, ma'am.
Whiteboard
Excuse
is
me,
not
ma'am.
visible, is it?
Yes, ma'am.
Can you see now?
Yes, ma'am.
So
Yes, ma'am. It's visual.
analysis
Yes, ma'am.
of
It's visual.
algorithm in two levels. One is before creating an algorithm, which is known as priori analysis, and one is after creating algorithm, which is known as posterior analysis. So priori analysis is done before implementing the algorithm. Various factors can be considered before implementing the algorithm. For example, like your processor speed, uh, like we also always care about the processor speed. Initially it was important, but nowadays your computers are very fast. They have powerful processors. So anyways, it's not that effective in case of implementation part. In implementation part, we don't care about the processor speed, but if you are going to build like heavy algorithm. For example, in early days, we had memory limitations, right? Nowadays, memory is not a problem. But earlier time, memory was an issue. It didn't have like abundant amount of memory in computers, right? So that was your priori analysis. Before implementing the algorithm, we check different factors. For example, like processor speed. Okay. And posterior analysis is your practical analysis. Okay, that means in terms of implementing the algorithm with the help of any programming language. So if I say this is theoretical part, this is practical part. Okay. So posterior analysis basically evaluate that how much running time and space taken by the algorithm. So whatever complexity we are going to learn now is your posterior analysis. Okay? We care about two things, time and space complexity. So time complexity means the amount of time required to complete the execution. Okay? And the space complexity means what? It's the memory required by the algorithm during the course of its execution. Okay? So an algorithm's space complexity is the amount of the space required to solve a problem and produce an output. Okay? So for an algorithm, the space is required for what things? There are different components are there. Okay? First, we need space to store the program instructions. Right? We write the program in a line by line way. Line number 1, line number 2. Those are set of instructions. So we need space to store the program instructions. Then we also need space to store the constant values. Remember, in a program, sometimes we define variables, we define constants, we define control statements, we use functions, and so on. Okay. So all of these things require or take some memory. Okay, so we need storage or space for the program instructions, for the constant values, for the variable values, and to track the function calls, jumping statements, etc. Okay, so we can divide these four types of things into instruction space, data space, and environment space. Okay, so space complexity we can find out with this one. Okay, S space complexity of an algorithm C equal to SPI, where C is the fixed part and SI is the variable part of the algorithm which depends on the instance characteristic. Okay, another way to write this thing is another word is there which is auxiliary space. Okay, so the extra space required by the algorithm is the auxiliary space. Okay, input space, input is already there. The four types I already mentioned. We need storage for program instructions. We need storage for constant values. We need space for variables. We need space for function calls, jumping loops and all. Okay, apart from that, excluding the input size, whatever extra space is required, that is known as your auxiliary space. That means extra space excluding input. Okay, so space complexity you can calculate input size plus your auxiliary space. AUXILIARY. Okay. Next comes the time complexity. In next class, we will see how we can find out the time complexity and the space complexity. Okay. So right now, just see what is time complexity. Time complexity you already know means how much time it takes to run a program and complete the program. Okay. So time requirement we always define with the help of this term T and N. Okay, and it can be measured and the number of steps provided each step consume a constant time. That means what? Remember, this is a flow chart or in algorithm. We go from one step to another, right? So every step, whenever you take any step, then we jump from one step to another. Each of the step consumes constant amount of time. Okay, for like addition of 2 bits takes n steps. Okay, so total computation time will be c into n. C is the time taken for addition of 2 bits. Remember, for addition we just write a equal to b plus c, then b equal to c plus a. So each of this instruction will take constant amount of time. Okay. Time complexity and space complexity, the concept is clear, the basic idea.
Yes, ma'am. Clear.
Everyone. priori, posterior. Can you tell me what will be I'm just writing the some numbers, okay? So suppose your algorithm is and you are going to add two numbers. So step 1 is the start. Step 2 is plus step. Step 3 stop. So what will be the space complexity here? Remember I said each and every variable and constant takes fixed space. Okay. So how many variables are there? How many variables are there? A, B, and C. 3 variables, right? So constant 1 time 3. Then there is one more constant here. So it will take one extra space. Okay. So time space complexity will become 4. Each and every variable and constant will take certain amount of time. Okay. So, sorry, space. So you just need to add up the space. Okay. This is a constant. So 3 variables and 1 constant. 1. These are just unit number. 1 fixed space, 2 fixed space like that. Okay. So space.
Ma'am, that means it takes 4 units, 4 units of
4
space.
units. Yes, right. So
Okay, ma'am.
space depends on the data type of the given variables and constant type, and it will be added or multiplied accordingly. We will see more examples later on. It will be clear to us. This is just simple one. Okay. So this meeting is going to end now. Okay. Okay. So space complexity, you guys already know. Every constant variable and instruction take one space. Now, how we see the time complexity? Time complexity is basically represented with the help of 3 things. One is the worst case, one is the best case, and the average case. So for any program, we always try to find the 3 types of time complexity. Mainly, we are concerned about the time complexity more than space complexity because nowadays space is available. Space is not an issue. All we care about is the time complexity. That means how fast is your algorithm. So time complexity, we check 3 things: worst case scenario, best case scenario, and average case. Worst case means the maximum number of steps it is going to take to execute the program. Okay. Best case means minimum number of steps it is going to take to complete the program, and average case is just the average number of steps it's going to take to complete the program. Just remember, everything will be in terms of the input size. Okay. Okay, continue this part in next. Just remember the three cases: best, average, and worst case. And we are mainly concerned about the worst case. Worst case means the maximum time it is going to take. Okay. Attendance is done. See you in next class tomorrow, right? Tomorrow we will continue this. So if you have any doubt, you can ask me anytime.